speaker is joining us from the United Kingdom. And over at UK, it's really very early, but that did not stop our next speaker from joining us this afternoon. Dr. Helen Webb is an assistant professor at the University of Nottingham. She is a highly experienced interdisciplinary researcher working at the intersection of society and technology. Professor Webb is interested in the ways in which users interact with technologies in different kinds of setting, and how social action both shapes and is shaped by innovation. Her projects typically seek to identify mechanisms for the improved design, responsible development, and effective regulation of technologies. A social scientist by training, she is named on the Lighthouse 3 list of brilliant women working in AI ethics. At the University of Nottingham, she is working on projects that explore the contemporary digital economy. So, with such a speaker, I'm sure you will have questions. So, we invite you all to type in your questions on the chat box, and Professor Webb will take in your questions live after the presentation. So, to talk about quality considerations for human centric computing, let's hear from a pre recorded presentation by Dr. Helen Webb.
Hello everyone, my name is Helen Webb and I'm really delighted to have the opportunity to speak at this AIBotics webinar. Due to time differences and certain other contingencies, I'm presenting this as a pre-recording, and I would like to give very great thanks to the organisers of the webinar for inviting me to be a speaker today and for making it possible for me to present in this way. The whole topic of human factors is such an important one for AI and robotics, and one that is central to the work that I do. So I'm going to begin my presentation by describing my own research interests and then make some comments on quality considerations for human-centric computing. I'm a socio-technical researcher, meaning that my work combines elements of the social sciences and computer science. I'm particularly interested in carrying out research to understand the connections between computing and society, looking at the ways in which users interact with computer-based technologies, the impacts they have on different demographics, and so on. I've very recently joined the University of Nottingham. I've just been working there for a few weeks, having before that been working at the University of Oxford for 6 years. In Nottingham, I'm based in the Horizon Centre. This is a research institute that specialises in exploring the potential of digital technology, looking at the ways in which people can have meaningful experiences in and through their use of mobile, internet, and other digital technologies. We take a human-centred approach, which I will talk more about in a moment, and prioritise research that understands human perspectives, respects individuals' privacy, and upholds community values. We also work in collaboration with industry, governments, and other organisations to conduct work that achieves impact, making beneficial changes to society, the economy, and so on. The Horizon Centre is doing an increasing amount of work on robotics, and in fact, this week is opening a cobot makerspace to explore the potential for collaborative robots. This will be a site for collaborations between academia and industry to create human robot and human AI manufacturing scenarios, and to conduct research into how people interact with robots and AI, and how AI and optimization techniques can enhance productivity. It will also be a space where members of the public can attend to learn about robots and AI and see demonstrators of new projects. I've added a link here on the slide if you'd like to see more details about this makerspace. Robotics has also been a part of the research that I do, most particularly in an ongoing project that I've been involved in called RoboTips. This project is led at the University of Oxford by Marina Jarotka, Professor of Human-Centric Computing, and is a collaboration with Bristol Robotics Lab, where the team there is led by Alan Winfield, Professor of Robot Ethics. RoboTips looks at social robots, loosely defined as those that interact with humans as part of their day-to-day function. So robot toys, assistive robots, driverless cars, etc. It starts on the understanding that these robots are the increasing focus of commercial development across the world. In the UK, they are not as advanced as current state of the art in Singapore and elsewhere in Asia, but they are receiving a lot of attention. In the UK context, there is a lot of uncertainty around them. How will social robots fit in with current social organisation? Will they lead to big changes in our working, home and public lives? Are they safe, and can we trust them? One example that is the focus of a lot of current debate in the UK and elsewhere concerns autonomous vehicles or self-driving cars. In the UK, the government is welcoming the development of these robotic technologies, providing financial and infrastructural support to accelerate their development so that they can come to the market and be present on our roads. There are still various issues to work out before this can happen with fully autonomous vehicles. These relate to the robustness of the technology and also questions about how they will fit into our lives. This uncertainty is reflected in the public response to the potential of self-driving cars, with engagement exercises showing that people see their potential for increasing mobility and independence, but have concerns over safety. There is awareness of the accidents that have occurred when self-driving cars have been tested, and caution over whether these new systems can really be safe and trusted. There are also broader concerns about the wider impacts of self-driving cars, such as whether they will lead to the loss of massive amounts of human jobs for those who work in transport. So the RoboTips project asks what kind of steps can be put in place to ensure that people feel robots are safe and can be trusted. We take central concepts of explainability, trust, autonomy, and so on to unpack how we can understand these things in the context of robot use. This leads us to develop safety mechanisms to be placed within robots. One example shown on the slide here is the development of an ethical black box for social robots. This is a data recorder that is placed within a robot. Much like flight data recorders used in aviation, this data recorder constantly collects information about the robot, its AI decision-making, and environmental features around it. This means that when some kind of accident occurs, the data in the ethical black box can be used in a process of investigation to work out what happened, what went wrong. What was the cause of the accident? Was it the result of some kind of robot malfunction or the robot being used incorrectly? Then once this cause has been identified, steps can be put in place to ensure that the accident doesn't happen again. In addition to this kind of safety feature, in RoboTips, we also make design recommendations to guide the work of those developing robots so that their products can address people's concerns and foster trust, and also make policy recommendations and produce standards so that the overall framework for industry is one that recognises societal concerns and pays attention to questions of societal acceptability. This process produces better quality outcomes, better in the sense of the robot products themselves and the ways in which they address societal considerations. And this, for me, is what the human-centric approach is about. When we conduct computing in a human-centric way, we are enhancing the quality of the computing systems we are interested in. We remember that the system is going to be embedded in a social context, to be used in a workplace, at home, or in public, and that it will interact with humans in direct and perhaps indirect ways. The extent to which the system is successful will depend upon the extent to which the human-system interaction is acknowledged and accommodated, and the extent to which human users and stakeholders will accept and value this system. This will depend on how much they feel it has been developed with their best interests in mind, and how much it will fit with their current practices and their needs. These issues can seem very obvious, but the history of development has many examples of projects that fail because they fail to recognize them. New innovations have been developed and deployed, often at great cost, without consideration of the physical environments they will be used in, without attention to the cultural norms and expectations of the target users, and without asking questions about the unintentional harms the system might cause in terms of physical harms, loss of privacy, loss of human autonomy, bias, and so on. And without asking the question, do individuals and society want this new innovation? Will they see it as providing benefit? Will they use it? And will they accept it? Being human-centric means we forefront the human perspective. This might be conducted in a variety of ways: analysis of human-computer interaction and issues of usability, How easily are individual users able to navigate the use of a system? Is it accessible to them? Can interfaces be designed to be intuitive and be accessible to users with different kinds of need? Can we undertake various kinds of studies with users themselves to observe how they make use of technologies and how these usability issues can be optimized? A human-centric approach can also bring in an understanding of social factors into the requirement solicitation phase of development. So we might ask, in what kinds of contexts will a system be used? What kind of human routines and environments will it be deployed in? And how can it be designed to align with these routines and contexts in both micro and macro ways, so that when it is deployed, it fits smoothly into that context and does not cause disruption? To do this, we can spend time in those settings themselves, observing what people do, how they interact with others, how they currently conduct the tasks that a computing system might be brought in to assist with, considering what kind of challenges or difficulties they face that a new system might help them to address, making tasks quicker, easier, or less hazardous. The human-centric approach can also involve asking more fundamental questions about the ethics of computing systems and their development. It's about considering why we need these developments and what purposes they serve. A fundamental question is, how can a computing system better support human flourishing? Can it empower people? Can it help people to feel safer in their day-to-day lives? Can it overcome societal inequalities or solve some kind of social problem? What are the ambitions and values that a society has, and how might the development of a new technology be able to assist with that? At the heart of this, it's about asking, what kind of society do we want to have, and how can technology help us to achieve it? When we begin with these kinds of fundamental questions and spend time engaging with them, it means that the outcomes of innovation are more likely to be ethical, to promote human flourishing, and be accepted by members of society. They will be better in terms of quality and results because they meet societal values and needs. So to me, this is what the human-centric approach is about, and its connection to quality is very straightforward. All of these human-centric factors are drivers for quality in the products that are produced. This relates to thinking on the individual scale about the usability of a system and the interactions between an individual user and that system. Thinking about the human context in which a system is used to develop social as well as technical requirements for it. And thinking on an abstracted ethical level about what technology adds to society and how it relates to societal values. This approach to understanding human-centric computing as a driver for quality is influenced by an initiative known as responsible research and innovation, also sometimes just called responsible innovation. This is an initiative that has emerged over the last 20 years and become very influential across academia, industry, and policy. It has been promoted a great deal by the European Union and is now also part of regular discourse in the UK technology sector and is promoted in policy guidance here in the UK. RRI is often characterized as doing science and technology with and for society. And here is a longer definition from the scholar René von Schomburg. RRI is a transparent, interactive process by which societal actors and innovators become mutually responsive to each other, with a view on the ethical accessibility, sustainability, and societal desirability of the innovation process and its marketable products, in order to allow a proper embedding of scientific and technological advances in our society. We can think of RRI as a set of good practices for ensuring that research and innovation benefits society, meaning individuals, communities of people, entire populations, and also the environment. These practices are highly inclusive, bringing in relevant stakeholders so that their perspectives can be listened to and their concerns can be acted on. We bring together actors across society, researchers, citizens, policymakers, business, third sector organizations, and so on, to work together during the whole research and innovation process. We take steps to collaboratively identify the potential impacts of a new innovation, the positive, negative, intended, and unintended impacts, and work on this to positively influence the trajectory of development. Having identified the positive impacts, we can take steps to maximize them. Having identified the negative impacts, we can take steps to mitigate them. This might be in the form of design changes, for instance, adding in fail-safes to a robot to prevent physical harms caused by collisions, or using more inclusive data sets for the training data in an AI system to make sure that risks of bias are avoided. So once again, the connections to quality are very evident. ROI is not about constraining the innovation process or slowing it down, but is instead about opening it up. It broadens traditional research and innovation processes to include the involvement of society very upstream, to forge a creative space where important decisions can be made that will result in better innovation outcomes. Better in terms of the performance of the technology, and better because the outcomes of innovation align with the values, needs, and interests of society and are more likely to be used, accepted, and welcomed. I'd like to finish by spending a bit of time on a particular example to consolidate these arguments I've been making about human-centric computing as a driver for quality in development. So let's return to the example of self-driving cars. Cars capable of operating with no human impact have the potential, according to some, to replace human-driven cars entirely and create a new form of market in transportation. They can offer many benefits to society, but there are also risks that might affect their uptake and societal acceptance of them. If we take a human-centric approach, what kinds of issues should we consider to forefront the human perspective, and in doing so, enhance the quality of the final product? How can we bring in societal actors into the development process in keeping with the responsible research and innovation approach? And what kind of concerns might they have? There are a wide number of issues we could mention, as self-driving cars are a fascinating and potentially transformative technology. We need to pay attention to the usability of the system in terms of the interactions between the car and human passenger. If the car is to have a fail-safe that requires a human to take over as driver in some situations, this needs to be achieved smoothly, quickly, and in a way that is intuitive to the human. More broadly, we could consider the need for explainability mechanisms so that human passengers can understand some of the behaviors of the car, which might otherwise appear strange or unsettling. There are also contextual issues to consider in terms of the environment around the car and recognizing that these can help to elicit the human-centered requirements for the technology. How do people around self-driving cars interact with them? Pedestrians, cyclists, and so on. And how can this be done safely? How can safety and trust be assured? How do adverse incidents and accidents typically occur? What kinds of interactions between human and machine behavior arise when they do? How can we understand them so that we can preempt them and build systems that avoid them occurring or minimize the harms that take place when accidents and incidents do occur? Finally, there are many ethical issues about the wider impacts of self-driving cars across society. Will there be a loss of jobs, and how might we assist those who lose their professional roles? Who will have access to the massive amounts of personal data about journeys and so on the self-driving cars will collect? In what ways will that data be used, and will it threaten the privacy of individuals? How can we make sure that everyone benefits from self-driving cars, that the benefits that self-driving cars can provide are evenly spread and that no demographics in society miss out on them? For instance, in remoter parts of the country where specific attention might be needed to be paid to upgrade infrastructure to ensure that self-driving cars can be deployed there. These final questions are, of course, not ones that engineers or developers can answer by themselves, and they should not be expected to try to answer by themselves. As the responsible research and innovation approach shows us, it is by bringing societal actors together that we can address these kind of fundamental issues and pave the way to better outcomes. When industry joins with academia, policy, and wider society, we can come together to positively shape the innovation process. This functions as a major driving factor for quality, as it ensures the safety, trustworthiness, usefulness, and acceptance of the products of innovation. It has been a real pleasure to have the opportunity to talk to you, and I hope my reflections on the topic of policy considerations for human-centric computing have been of interest. I've put on my final slide some references to articles from the RoboTips study that you might like to take a look at. And I always welcome conversations with others working in this area, so I've included my email address on the top of the slide as well. Thank you very much indeed for your time and attention, and I hope that you enjoy the rest of this webinar.
Thank you very much. And now we are joined live by Helena. Hi, Helena. Good morning to you.
Hello, good morning from Nottingham. Good afternoon to you.
Thank you so much. So, and really, thank you for your sharing. We have a bit of time to take in one question. We have a couple of questions sent in to us. So, here it is. A question to Professor Webb. In the design of human-centric solutions, what is the degree of automation suggested so that we do not make the humans redundant?
Oh, I think that's an excellent question.
It is. It is.
And, you know, it's one that a lot of the debates around AI at the moment, you know, center on this question: how much automation is safe, how much of it creates ethical problems in terms of human de-skilling, loss of employment, and so on. And I think the answer is that it needs very careful consideration, and probably on a case-by-case basis as well. I think there's probably no one answer for every single system. I think we have to think about it in the context of how's the system going to be used, what kind of industry is it for, who are the human beings affected by it, what are the safety critical problems involved. But I think it does need very, very careful attention.
Right. So thank you so much for that. And thank you for your presentation. And thank you for joining us too early in the morning out there in